Hello class. So this video is now going to look at nitriles. The previous video we learned how to make nitriles, and now we're going to look at reactions with nitriles. And the first one is the hydrolysis of nitriles. That is where you take a nitrile and you treat it with an aqueous acid and you add some heat to it, and that's going to convert it into a amide. But if you keep the reaction going, so if you keep it in the acid and the heat and you keep letting it react, it's going to react further into a carboxylic acid. So nitriles, we can stop them at the amide, but if we let them keep reacting, it will keep on going to the carboxylic acid. So what we need to do is make sure we understand the mechanism and on how that happens. After hydrolysis of nitriles, we will take a look at, we could hydrolyze nitriles under basic conditions. So here you see it's under acidic. So this is acid-catalyzed hydrolysis of nitriles. We'll look at base-catalyzed hydrolysis of nitriles. We will then also take a look at how Grignard reagents react with nitriles and things like that. Okay, so let's start off by taking a look at the mechanism of this transformation. So what we're going to do here is our goal is to convert this nitrile into a amide. That's the first step. So under acidic conditions, we have an acid, we have a base. So that's going to protonate the nitrogen on the nitrile. So that's going to be a positive charge, and then we generated our water. Okay? And now what that has done, it has activated this carbon. Because now the water can attack that carbon like so. And every step of this process is reversible. So now what do we have? We have carbon, double bond nitrogen, the lone pair, and then we attached some oxygen, just like that. And so then we'll come down this way. What do you think the next step's going to be? Well, we have a lot of water present, so we are going to do a proton transfer step. And that's going to give us that would be a lone pair, and then the OH, like that. And then we also generated some more acid from the water abstracting that proton. Okay, remember our goal here, our end goal is to get a amide. So what's next? So we've generated an acid here. And what could we do here? We've done the proton transfer. But if we want our amide, let's just kind of over here. What is our amide going to look like? It's going to look like that, right? We have a nitrogen with two hydrogens. When I look at this nitrogen, I see that there's only one hydrogen. I know I have to get another hydrogen on there. Okay? And so what we could do here is we see that this nitrogen has lone pairs, so it's basic. So if we expand out this acid or this hydronium, just expand it out like this, oxygen H2, we could see another proton transfer step that could occur. We see the nitrogen come in with its lone pairs and abstract that proton. So what's that going to give us here? And then double bond nitrogen. And now we have a positively charged nitrogen there. So can we see a resonance structure with this guy? What if I brought that lone pair down and that like that? What does that look like? We have a resonance structure here. Double bond O. So that's going to be positively charged. We now have a single bond nitrogen and then two hydrogens like that. So that's a valid resonance structure. And then if we just do a proton transfer step, we can what? Get to our product right here. So what did we generate? We generated some water. So there's water present. We'll put it right here. So that water is going to act as a base and do a proton transfer to give us our product. And there's our amide. Now if we continue on and allowing this amide to react with the acidic conditions and some heat, we are going to convert that into a carboxylic acid. And we have already talked about this mechanism right here, going from an amide under acidic conditions to a carboxylic acid. So I'm not going to redo that mechanism, but make sure you know that one. Okay? So this right here was the hydrolysis of a nitrile. So the next one, we are now going to change it up and look at under basic conditions. We will do the hydrolysis of nitriles. Overall, this is the transformation where you take the nitrile, treat it with some base and heat, you'll form your amide. But if you don't monitor it carefully and let it continue to react, you will then form the carboxylate. And then you would have a second aqueous workup step to get it to our carboxylic acid. So the overall same transformation under basic conditions as compared to acidic conditions. You get the same product, just it goes about it in a little bit different way. So what do we have here? Well, we have our hydroxide. And so we're under basic conditions. So when you have the hydroxide, now why is that negative? Because there's three lone pairs. We have it just going to directly attach the nitrile carbon. And every step of this mechanism is going to be reversible. So what do we have here? So our carbon, OH, double bonded nitrogen. There's already a lone pair there. Now there's another one. So that means that's going to have a negative charge, and we just generated some water. Now let's expand out that water molecule. Let's do it like this. Now we can do a proton transfer. Like so. And we have our hydrogen right there. Plus hydroxide. Okay. Now, we could have a resonance structure. Let's see here. What's the next step? So we have some base here. What we could do, what if I drew a resonance structure? What if I took the lone pair here, go like this? What would we get? I could see something like that, right? So now I know, hey, that hydrogen right there is acidic. So what could happen is the base here can come in and abstract that proton like so. And then that would give us negatively charged. And what did we just generate? We generated water. So we could see this negatively charged species come in and do a proton transfer. To form our nitrile. Not nitrile, sorry, our amide. Plus the base that we just generated. And then we could see if we take our amide here, just following the steps, we can get it all the way to our carboxylic acid. And I've already shown you the mechanisms for those steps already. So next, we are going to take a look at how Grignard reagents react with nitriles. Now we're going to take a look at a reaction of nitriles with a Grignard reagent. So let's treat it with a Grignard reagent that looks like this. And then step 2, we have a acidic workup. What is our overall transformation here? It is going to be the ketone. That is the overall process when you are treating a nitrile with a Grignard. You have this methyl group right there being added to the ketone. But the way it does it isn't straight from the nitrile to the ketone. It's actually a stepwise process in which you take the nitrile and you treat it with these conditions right here. Okay, CH3. In step 2, you're going to treat it with the acid. What you're going to get is let's see here, double bonded nitrogen, CH3 like that. And that guy is the amine. Now this amine, when it's under acidic conditions, we have learned that it's going to react with the acid to form the ketone. So we're going to hydrolyze the amine here to give us the ketone. Now this transformation of going from the amine to the ketone we have discussed already in previous videos. So make sure you understand that mechanism. But how does before this, how do we get here? What's the mechanism of that? So let's do that. And it's really simple here. We know that the Grignard, let's draw it like this, is very basic. And so what it does is it comes in and just does a nucleophilic attack like that. And so that's going to generate this species. Double bond to the nitrogen, negatively charged, and then our CH3 right there. And then you have the step 2, which you're going to add your acid. And when you add your acid, you are going to now generate the amine. Do you see how this and this guy's the same? But you are still in acid. And it's really hard to stop this guy here at the amine when you're under aqueous acidic conditions. And that's going to then hydrolyze into the ketone. Okay? So that's the mechanism with that. The next reaction that we're going to take a look at is the reduction of nitriles. And this is going to be the last reaction for this video. Recall if you take a carboxylic acid and you treat it with lithium aluminum hydride and then do a acidic workup, what's the product going to be? That's going to be an alcohol. Right? Well, we can do the same process with nitriles. We could take a nitrile and treat it with lithium aluminum hydride. And then in step 2, do a aqueous workup. You see how that's acidic and that's aqueous. I'll talk about that in a minute. But what's that going to do for us? That's going to give us a amine. So we can generate amines from nitriles just by doing a reduction, lithium aluminum hydride. Now the reason why we don't use acid in the aqueous workup step like we did up here is because if we used acid, then we would protonate that guy and make the ammonium derivative, and we don't want that. So using just water won't protonate that amine and give us the product that we want. So we'll just put a 2 right there. Okay. That's the reason why we only use water in this one. Okay. So those are the reactions that you need to be aware of. The mechanism for this guy is going to be very similar to this one. So just try that one out on your own and see what you come up with, okay? So as usual, if you have any questions or concerns, please reach out. I'll be more than happy to help.